Test, test. Test, test, test. Hopefully, welcome everyone. Let me know if my audio is too low or too high, and I will change it. Um, Second live stream ever, so we're still working things out. I had a few issues with the camera, but I was still able to start a little bit earlier than I was able to, so that worked out nice. Let me open up the stream. See, got anyone viewing? Got a few viewers. Go. Let me just go so I can see the chat. Set up my stream deck. I'm still not too great at this. So, for who's in here today, we're going to be starting casting the propellant for SN4. We're definitely not going to get through it fully because this is a multiple day project, but we're going to, for the first segment, it's going to be a Q&A, so a little low. Okay, let me know about, we're at negative 13 decibels. Let me know how it sounds now. It might be too high now, who knows? But yeah, so that's what we're gonna be doing today. We'll also be filming behind the scenes for the SN4 video as well. So it's gonna be a slight slower stream. Just hang out. There's the stream warning. Oh boy. And also, is the connection working good for everyone? Connection's good. Okay, my end it says warning for some reason. Um, Warning streams currently bitrate is lower than recommended. Okay, it should be fine. Let me know if it starts getting laggy. I can sort things out, but it's still low. Okay, I'll put it up. How about if I just put it full? How does it sound now? This is up all the way. Maybe it's good now. Okay, all right, perfect. So this could be a Q&A if you want to ask any questions about what I'm doing or any other questions I could try to answer. Yeah, so we're pretty much gonna be pouring the propellant for SN4. I'm gonna be taking some videos for this is a little behind the scenes. I'm gonna be taking some videos for the next video. SN4's parts should be here by the end of the week, hopefully, mid by the end of the week. Um, Once the parts come and once this propellant's casted, it'll only be a day or two until I'm able to test. Most of the parts come almost finished. I just got to do a few things to the parts, but to where we're at right now, I got right here. I know you can't see right where my computer is in the camera. I got a nice wall set up for getting nice videos for the parts when they come in. I'm gonna really try to upgrade the production on this video. We'll see. If you like it or if you don't, let me know in the next video. But I'm borrowing my friend's FX30 cinema line. Really nice camera. So I'm gonna video with this. If everyone loves it, and okay, the live stream just went. Okay, I don't know what just happened there, but live stream's back. It just got blurry for a second. But yeah, so I'm gonna be using this FX30 cinema line to. Okay, let's do it again. Oh boy. Yeah, I can share my composition. I have it on a little formula sheet right here. Hopefully that blurriness doesn't keep on happening. Because right now, my camera that's up there, it's the camera that's up. My overhead camera is connected Bluetooth, and obviously those connections aren't as stable as if it was wired. So for the future, if I start doing a lot of live streams and this becomes normal, I'm gonna definitely upgrade my setup. Um, I got You can kind of see I got white backdrops now. To help out with the video. But yeah, the composition, if you'd like to see it, I can let's see. So it's pretty much just potassium nitrate, red iron oxide, and sorbitol. But here are the percentages. If you want to take a screenshot, and then, yeah, if you want to take a screenshot of that, let me know if you didn't get it. I can always put it back. Um, it's pretty simple. It's NACA modified because it's where I got it from, but I modified it. So um, modified to my liking because during SN2's test campaign, I was able to test a lot of different propellant additives, and I settled with this one. It worked great for SN3, so we're gonna continue with SN4. If there isn't a big issue, then what I'm gonna go with. Worked out good so far. So let's. I like to shake up the my milled potassium nitrate well before I'm gonna use it because then there's dust everywhere. But this helps break up any clumps from moisture. It's blurry again. Let me check. Okay. Yeah. Let me know if the blurs keep on happening. They might just happen every so often. I don't. On my end, I'm not seeing blurs. Um, Make sure you're also live. You're fully caught up, so it's completely live for you. So if there's an issue, then you can let me know, and then I can look at it live. Because I have a on my computer over here, I have a browser set up with my other YouTube channel, like my main YouTube channel that I watch YouTube videos on. Um, and then my Aero Propulsions channel is like a side channel. That's I'm keeping up with chat in there. Oh, the list was blurry. Okay, I see. Um, that might just be I'm streaming 780, I'm pretty sure. Um, no, 1080 60. Make sure you're on 1080 60 FPS in the YouTube quality. But I can put the list up there again. Um, if not, reach out to me. My email is aeropropulsions@gmail.com. I'll send you over the document of what I'm using, but we'll try this one more time. If it doesn't work, then just email me. How about that? My end, it looks really crisp, but it depends on. Let me know if you got it. Hopefully. Here we go. Let's go right here. I keep all the lists on the wall over here. I have all my instructions. It's really smart to make instructions if you're doing something like this. Right now, I usually don't. I've done this. Well, we've tested SN1 6 times, SN2 4 times, and SN3 2 times. So I got 10 times, right? No, no, 11. Or no, 12. Yeah, 12. I've done this 12 times. And that doesn't even account for all the times I've done it and it failed or times I've just made test grains. So I've probably done this over 15 to 20 times. So I still have the instructions over to the right or left of me, right over here on this wall. Um, but I have a pretty, it flows pretty nice now. The propellant, learning how to do this propellant and all the issues, and really streamlining it. So right now, this type of technique I do. I don't think I've seen it on anywhere else. It's just I started off by watching YouTube videos and I kept on refining everything until it works for me. And this is what works the best. So I do a multi-pour. I pour 4 times. That's SN. Well, SN3 was 4 times. This might be 3.5, 3 times because there is going to be less propellant overall in SN3. A little less, not by much, but here are my tubes. Are just normal craft cardboard tubes. And then in here, oh no, that's wrong. This is the coring rod. This is the big coring rod. And then in here, I have the Finicil. And I got the base plate, which the Finicil slots in there perfectly. And then I have the top plate where the cardboard tube goes through, and then the coring rod. And then we just have some other extra bolts when I finish off the top of the propellant, but we're not going to be doing that in this live stream. If you guys enjoy this live stream, please let me know. I can do a live stream, honestly, for every segment I cast. So this live stream is going to be casting the first segment. That's always the most complicated and the longest segment to cast because that includes the finisil. So it's definitely the most difficult. Let me get the hot glue gun going while we speak. So I'm ready by the time I get up. So yeah, that's how I do it. I'll explain it one more time. Let me just get this ready. Hot glue guns on. Get all organized over here. Organization is also a very important step. You gotta be organized because sometimes steps come up quick and you wanna know where everything is and not mess up anything. What's up, Ryan? Okay. So the technique we're gonna be doing today is a multi-pour technique where I pour one layer, just pull this, pour one layer, let it harden, pour another layer, let it harden, pour another layer, let it harden, and it'll be done. So this is a pretty, this is what works out great for me because sure, you can make a huge batch and then cast it, but then there's going to be a lot of bubbles. And I've tried it before, but a lot of air bubbles, and it's way more difficult to manage. So this multiple cast technique works great for me. So first, we're going to be also I build the grain segments up by segment because obviously this is how big the cardboard tubes come. I haven't been able to find any longer ones, so I'm just going to use these, and this works great as well. So first, I will slot in the finisil section. Then I will grab this segment. I'll put it in there, and then put the corn rod in, and then I'll pour the propellant up to around halfway, and then for the next pour, then I'll tape the next segment on, pour, and then tape this next segment on and pour. So it's a modular approach to it. And we're blurry again. I don't know what's going on with this. Okay, this blur doesn't look good. Can you guys still hear me when it gets blurry? I don't know what's going on. Um, Let me check one thing real quick. So how is the audio? Does the audio sound good and clean? Yeah, hmm. I'm gonna need to catch it with a ladder next time so I can look up there and see why it's going blurry. Okay, at least you guys can hear me because it doesn't go blurry for too long. So first, I will grab this. I'll just cut off these little ends because sometimes these ends come loose. This is just a cardboard roll. I'll cut off just the inside of these ends so they don't come loose. Step definitely isn't necessary, but it just helps me out be sometimes. Just becomes messy. Boom. All right. Go back, let's throw out this. Okay. So here's this first segment. Just make sure. Sometimes I get these from Amazon. Sometimes they come really bent. I can show you, for example, some of these, unfortunately, I can't even use. Like, look at this one. This one's pretty messed up. It's all delaminated and also all bent everywhere. These sometimes are a little bent. I can bend it back, but at least, yeah, some of them, they're cheap. They're not too expensive. So that is a good thing. All right. Let's Yeah, it's still saying, okay, it's still saying bad connection, but if it's clear for you guys, I guess that's no issue. All right, and then for the Finisil, one thing I've learned is you got to use a lot of lubricant, or I use grease. I'll clean it off after, so it's not in the propellant. Same thing with the base plate, but more for the Finicil because I've had times where I poured the whole grain and then either this thing sticks in there and I gotta melt the grain down and break it open, or I'm hitting this out and it when it comes out, it tears out with a lot of propellant on it. And then obviously that renders the grain useless. And the grains are relatively cheap to make. Potassium nitrate, red iron oxide, and sorbitol is pretty cheap, but it's just the time that goes into making these grains. If if something like that happens, it'll set me back a week because I also need to wait a few days after the last pour to make sure these really harden for the test because I wouldn't want something that's not hardened. Then when the propellant's burning, it can tear out and little chunks of propellant, unburned propellant can come out of the nozzle. I had an issue on that on I think SN2's last static fire when I used SLS. I used SLS to make the viscosity of the propellant higher so it pours better, but I learned that it makes the propellant less hard at the end, so some unburnt propellant chunks can tear out during the static fire, which obviously you don't want unburnt propellant coming out because then that's unburnt potential that you could have used. All right, so then I use some Q-tips. I won't be filming too much of this process because I already have a video on this and I don't want to add too much into the SN4 video of casting propellant because I don't think it's, I definitely think it's one not too interesting compared to the other parts. And also I have another video on it if you want to see more. I cardboard and clear. Okay, so that's a good question, Ryan, because I do have some of the cardboard liners from past static fires. I'm not going to take them out of the plastic wrap because this is the SN3 liner. Oh, yeah, so I'm not going to take them out of the bag because they stink and they also have soot all of them. But this is the SN3 liner you can see. But yeah, you can see this is near the bulkhead. So it burns a lot near the bulkhead. Also, there was segments to this. It didn't look exactly like that, but I threw out the small segments. And this was more near the nozzle. Um, it definitely does burn through. This was from SN4's or SN3's last test. So see how it's all mangled because it exploded and landed, I think like 15 feet away from the test site. This is all mangled. So this one mostly burnt because it flew out and started to burn. But yeah, to minimize the burn through, personally for me, the burn through isn't really an issue because I have this thick aluminum, and even after six static fires of aluminum, it gets just some, I don't even know what that is, but it's still smooth. There's nothing melted. Just add some residue or buildup. But to prevent it from burning through, you can possibly use thicker cardboard. It really depends on how much propellant your rocket motor is using, how hot it gets, what type of propellant. Um, use PVC tube. PVC tube, I mean, it's cheap. It's good option for cheapness, but it also is very dangerous because if it explodes, I started off with PVC tubing. Um, actually, I can right here, over here. This is turning more into a Q&A than me working. Yeah, this is live. So here's actually this is SN4 of a different campaign, not current, but um, here it is. This is the old PVC tube. If you want PVC, it's not going to be reusable. I mean, technically, possibly you could reuse this, but it's definitely not great because it's all burnt in there. Also, you can see how I used uh, clay core on the bulkhead area. The nozzle shot out on this one because I think it either shot out or I removed it to check the inside. That was a long time ago. I did this a long time ago. like 2 years ago, but I have this out because I'm gonna make a video in the near future on how to make an easier motor because obviously these are pretty advanced and expensive. But what I recommend over PVC, because obviously PVC explodes, it's gonna create shrapnel, and that shrapnel could get in you, and then that's not good. Also, the relative density of PVC. I learned this from one of my videos. Someone commented the relative density of PVC and your skin and flesh is around the same density as your actual flesh. So it's very hard to see it through X-ray. So it'd make it very difficult to get it out of your skin. So PVC definitely, if you're going to use PVC, be very far away. I don't recommend it. What I recommend is this, another rocket motor I've been working on. It's frozen. Let me give it, oh, let me get up there to see why it's freezing. Okay. Here's another rocket motor I've done. These are, you can also see the bulkhead, the clay bulkhead in there. The nozzle must have blown out or I removed it. But these are thick cardboard tubing. These are kind of expensive. I'd say they're like 75 cents per one, maybe 50 cents, 75 cents per one. But this is a way safer alternative to PVC and it works pretty well. Obviously, it all depends on what you're doing. If you're going to make a very high powered rocket motor, cardboard will just explode. Same thing with the PVC. But if you're using pretty low power, you're not looking for your reusability because most of that stuff is non-reusability. Um, it's already, I don't know why this is up. I think I have an idea. So I'm pausing it right now. I need to put my, okay. Sorry, now it's moving because I was touching it. It's not great. I'm gonna put my phone on. I'm using my phone with continuity cam to screen mirror down to my Mac. I think it's doing that whenever I get a notification. So I'm gonna put my phone on do not disturb. So hopefully I don't get. Yeah, I am an aerospace major student. I'm in my sophomore year. Getting ready to transfer because I started at community college because I didn't know fully if I wanted to go for aerospace engineering, but then I learned that it is pretty cool, so I'll stay in it. So I'm gonna transfer to a four-year college and finish up my degree. Okay, yeah, the phenolic is a very um it's a good option. It's definitely more expensive. Oh, I'm just doing it again. It's definitely a better option than cardboard. More expensive. But cracking, that is weird. I don't know. Never. Which college? UB, University of at Buffalo. Okay, all right. So we're gonna get started now. If it stop freezing, I don't know what's going on. So we gotta lubricate the base plate and the finish sill. So we're gonna. I actually have. Let me know if you prefer this view when I'm doing wide angle stuff. And I also have this view when it's close up. I can actually there we go. Let me know if you prefer this. You can see it a little better. So we're gonna actually need to get more of this grease. Almost ran out. And I also use the same grease for around the O-rings. And also I'll probably use this grease at the pressure transducer area because it is rated for high temperatures, up to I think 700 degrees. Definitely getting hotter than 700 at some parts of the motor, but it'll work fine for a quick test. So I'm gonna first, let me know if you see everything okay. If you want me to zoom more in, let me know. I can always do that. It's not a big issue. Just greasing up this base plate. The worst thing that could happen is that it doesn't come apart after I finish all this work. As I was saying, it's a multi-day. We're not going to finish the grain today. If you guys enjoyed this stream and want me to do more streams like this for the rest of the propellant grain, working on all of it, let me know. I can do that. Okay, so I got a nice layer, probably very hard to see, um, of grease on the base plate. Now we're going to go on the finicle. Finicle, I really do try to get a lot on. Close-up's better, for sure. Perfect. I will make sure I'll get on this and do live streams as much as possible. I was thinking about, I don't know if this is once I'm able to unlock memberships on my YouTube channel, let me know if you would do this. I was thinking about doing informal videos every week about what I'm doing. The membership would only be probably like $2 a month, but it would just be another way to connect with all you guys. And also, let me know if you'd be interested in that. I would provide perks and a bunch of things. Probably I wouldn't do expensive at all, like $2 a month, not even 99 cents maybe. We'll see when we get there, but it wouldn't be anything that was very expensive. All right, so once I got them both lubricated, they go in they slot in like I was showing earlier, and I do come back and clean up because I want this to be very smooth because I don't want any bulges of this grease or else it's gonna create a pocket in the propellant of just grease. I want this very smooth. So I come over again once it's in with the friction with the lubricant uh, stays in pretty nice. So we're looking pretty good with this. Make sure this is okay. Because right now I'm trying to really get to the point where I'm able to make money off of these videos with ads because if I'm correct, you guys still see ads in the beginning of the video. I have YouTube Premium, but if you guys still see ads in the beginning of the video, if even if I'm not getting paid from them, correct? Because I really wouldn't add videos. I wouldn't really add ads to the middle of the videos because I think that's a pain. But I think it's kind of messed up that YouTube adds ads to the beginning of the video, even though I'm not making any money from it, and also I would rather just keep them off. Um, yeah, David. I'm doing a lot of this. It's been, oh my gosh, this is blur. I'm sorry. I know this is very annoying. I'd be very annoyed. Um, yeah, I got these instructions and pretty much the same way every single time. All right, so now that we got the finicle and the base plate lubricated, we can grab our first segment. I wouldn't say that I have this down to a fine art yet because we didn't get to the propellant pouring, and that could always mess up. I sometimes do mess up the first pour around the finicle. Um, at least it's just the first pour, so I'm not losing that much. But we'll see how it goes. I haven't done this in a long time. The last test, this has been the longest I've went without a test. The SN4, I'm really trying to. Well, I tried because I'm done designing SN4, but I think this is going to be the final iteration before the rocket. And we're blurry again. I don't know. See, I don't know what I should do. I could reset everything, but then I don't want to stop the stream. And let me know what you guys want. All right. So now I hot glue. Oh, I forgot a step. That's what happens. That's what happened. That's what happened. That shouldn't be too big of an issue. Huh, right when I wasn't looking at my sheet. I gotta look at my sheet. So, okay. Oh, we got I'm gonna this hot glue makes all these strings. Okay, we're gonna put that back there. All right. Sorry about that. Now I grab some tape. Extend the outer diameter. I don't know what is going on with this. This is blurry for a long time. All right, hold. Hang on, you guys. I'm gonna try something because this is not working. But I don't want to. Okay, what is going on here? All right, sorry guys. I don't know what's going on. My camera must it just went off. This has never happened to me before with anything. Bear with me. I use sorbitol because it um, so sucrose will break down if it heats up to a certain degree, a certain heat, and sorbitol pretty much doesn't break down to a higher heat. So I use sorbitol to so I can heat this mixture up hotter, so I'm able to pour it and it stays liquid longer. Okay, what is going on? What is going on here? I'm sorry, guys. This looks terrible. Um, Something going on with my phone. I'm not 100% sure. Should be black on your guys' end, black on my end. Okay. All right. I'm just resetting my phone. I don't know. Something's wrong with this continuity cam. It worked great. It used to work great, but I don't know if there's a new iOS update. I just need to get an actual camera to be up here. Okay. Oh my gosh. All right. If Let me try to work this out real quick. I'm sorry. All right. Back. Put it back in the clamp. But the only annoying thing is once it's in the clamp, it does this. Now it's off again. Let me take my case off or something. Okay. It's been a little shaky like that for a second. My mount right now is not the greatest. Now that's very All right. Let me just, sorry. Let me know if it's looking better on your screen. And right here, I'm just making the close up real quick. Close up is both the same. It's just digitally zoomed. Okay. All right. Let me know how this looks. Should be able to see everything. We can continue. Yeah, check it. I know. It's pain. All right. I think we're back. Please no blur. Here's close camera. Good. Everything's in frame. All right. We're back. So what I forgot when I was doing that last one was we need to add, we just need to add some tape because the diameter of the plate is slightly undersized because some of these cardboards are a little bigger, the tubes are a little bigger, smaller. So for the little bit smaller ones, I grab this tape and it's pretty much, I try this tape that has a little bit too much. So we're gonna grab this. I take some off and I pretty much just play with this. All right, there we go. Now we got that. So now it's time to glue. Let me just make sure everything is swirly. What do you mean about that? Um, okay, let me know what you mean. Now everything's sized properly. I will hot glue it all around. Also, let me know if there's any. Okay. All right. Everything's hot glued. Looking good. We can put the hot glue away. One step closer to propellant casting, actually, the pouring. There's a lot of prep work with this, but most of it's prepped and a little bit is pouring. All right. So, little piece. So how we're looking. All right. So this is hot glued down to the base. I can't really tilt it. I can a little bit because I don't want the finish seal to fall out. How we're looking. Now we are going to get this Exacto put away real quick. Keep the chat open. Once I'm pouring, I might not be able to answer the chat very quickly. I've got to focus on this. But I will go back and answer all the questions. Right. So you get this lubricated. Top plate doesn't need to be lubricated. It'll never touch propellant ever. So grab this, move this out of the way. Now, so you got that done. The rod is silicone, so it doesn't need to be lubricated. It will come out relatively easily. And the bolt, this is actually just a bolt that I cut off the top and threads um, to make sure this stays rigid. So you got this. Now, boom, boom. Take this off. When I'm measuring the propellant, I'll keep this on low. This will preheat a little bit. All right. So we got the thing. Let me go close for you guys. I use a mason jar to mix it. Just a paper towel in there from last time I cleaned it to keep the moisture out. Okay, so I got the milled potassium nitrate, granular potassium nitrate, and then the sorbitol. So I like to start off with the sorbitol. So we're gonna grab the sorbitol. Make sure everything, this is very important, having everything labeled because this is going to be a multiple pour. So I'm going to be pouring this multiple times. So having everything labeled, I don't got to go back, clean everything, and then, it's just a pain. So I got everything labeled, and this will only be used for sorbitol, potassium nitrate. I know I have granular and milled. Those both go in the same thing. They're just different size, mesh size. And then I got a red iron oxide small one because not too much red iron oxide goes in. We're gonna put everything that we don't need to the back right now, so we don't. All right, so let's start off with sorbitol. So we're gonna get sorbitol on here. Let me go here. I'm gonna actually duplicate this, and we're gonna get another scene for pouring the propellant. So I got this one, this one. Let me know if you guys like that. That's far one, close one for when I'm working on the mat. I have a silicone mat here, and then I have a close for when I'm pouring it. So we'll grab this on here, tear this sorbitol. This is just from Amazon, the sorbitol. All right, so we're gonna look on the instructions. Instructions are taped on the wall right here. So let's see, sorbitol 52.5 grams. So we'll measure this out. Almost there. Oh, a little bit over. 52. All right, come on, man. Let's go. All right, here we go. Yeah, from the sorbitol. Right, then I add it to the mixing container very slowly to make sure we don't lose any. We will lose a little bit inside the actual jar but the formula I makes, obviously, none of this needs to be exact. We lose the littlest bit, but you can barely see it. Less than 100th of a gram, probably. All right, we got sorbitol in. Put the top on now because we got stuff in it. Now we're gonna go over. I always do. It turns the scale by. I had to press tear. So I always do the milled first because some of the milled potassium nitrate will get stuck in this. So then when I put the coarse granular, it will grab some of it and get it all in there. All right. Tear this out. We got the milled. This milled stuff is tough. Um, it gets everywhere, so you gotta be very careful with it. It's like powdered sugar. All right, so let's go over here. Milled 34.13. So we'll measure this out slowly. Almost there. A little too much. 34.13. So We're gonna keep it at actually 1.5 because so the milled potassium nitrate, it's a pain because it has all these clumps. So we come over here. I use this plastic bag. This is just for the milled potassium nitrate. That on there, tear that out because we're gonna do the granular after this. I'll just add out any of the clumps. These clumps are just inevitable. I've tried milling it down and processing it with no clumps and putting it back in the jar, then it gets more clumps in the jar. So it's tedious to do this every single time, but it definitely makes sure there's no clumps. The clumps obviously is not a great thing. All right. And there'll always be some very small clumps, but that's fine because the small clumps are probably the same size as around the granular. So there's nothing bigger, nothing too big. All right. That is looking good. All right. So good. That's why I put a little bit more in because it's all a little bit's gonna always stick to the bag. We're gonna grab scissors wherever I put the scissors. I was just talking about organization. Okay, I'm gonna grab our mix. Cut off the end of the bag. And we'll get this all in here. Try to get as much as possible, but it'll be impossible to get it all. So that's why I always put a little bit more. All right. So you got the milled sorbitol. Now we got to do the granular. Use granular. Like to hit it to make sure all of it's down. Now, let's go this. Milled gets 60, or granular, sorry, 63.38. All right, 63. Explain. Oh, just one. 4, 39. A little bit. Come on, a little bit. That goes to 37. Okay, a little bit in there. All right, good. Move the granular to around to grab any of that milled that's still in there. Add it to the jar. Now, this nitrate's done, Borbo's done, we'll go over here. Now the final is the red iron oxide. This stuff is a pain, it stains everything. So I gotta be very careful with it. Don't like getting it anywhere, it'll stain anything. This is pretty much just rust, if you don't know. Helps accelerate the burn. I've learned that I put 1.2%. I've learned that that helps out a little bit. So we're gonna do 1.87. One more scoop. 5, 6. 7. 1 is arguably probably one of the most important to make sure this is exactly 1.87. Don't want. I need to make sure with multiple pours this is consistent through each pour, the 1.87, because then you can have uneven burning of the grain, which I haven't seen inspected yet. So I'm doing a good job with that one. All right, we'll grab the mix. Make sure all that's in. All right, so we got it's on tight. We're gonna mix it up. Guys, like turn off the scale. We'll move the. This is already warm now. It's not hot, but it's on low. This is warm. Keep that on there. Grab this. Grab everything for the next setup, the next stage of this job. Okay. All right. We'll make this really good. And we gotta wait a second for it to all settle because you can see there's a lot of dust in there. All right. We'll wait for that to settle. I can answer some questions. Do you have a Discord server? No, but I was thinking about making one. That's a good idea. Um, hello T Money, what's up? Yeah, Discord server. Let me know if you guys would join the Discord server. I think that would be pretty cool. Everyone can help each other out. Also, don't forget if you haven't liked this stream yet, please like it. That would be amazing. Only got 6 likes. We've had 30 people stop by, 40 people stop by. Experiment with mixing software. Wonderful. Yeah, so sulfur was something I was looking into. It's a pretty good, it's pretty smart because it will lower the startup temperature to actually ignite the powder. The only thing that scares me with sulfur is now that if I'm decreasing the temperature that it can burn, then I'm decreasing temperature that it can burn when I'm melting it. So that kind of scares me a little bit, but it's definitely something to look into for the future iterations. Um, Obviously, I think SN4 is going to be the one of the last iterations of this type of rocket motor, but obviously with an iteration, I mean the actual hardware. The propellant will always be able to change. Propellant can always change between static fires and keeping the same hardware if the propellant was within range. Um, Software about two. Okay, I see. Um, Also, you can share your study material. What would you like where I learned this stuff from, or um, please elaborate on that. Yeah, I could. Yeah, yeah. Definitely, a sulfur is definitely a place to look into. Once I'm waiting for this to settle, I'm gonna take a quick video. Also, for the people who aren't here, I'm borrowing my friend's pretty good camera. It's a FX30 Cinema Line. This next video, SN4's video, I'm gonna really try to get try to upgrade the quality of it. So let me know if you like the quality. If you do, maybe I will look into buying a camera like this. I probably wouldn't buy this high end of a camera, but I'd buy a better camera. Because this camera does take amazing videos. Um, looks great. Adds a little cinematic view to the video. All right. So camera's off. All right. This is heating. Hands warm. Grab our stir. These mix. So yeah. So once I heat up this into a liquid, I'm gonna pour it in. But I'm gonna pour it in without the coring rod first, so I can really get around those finical grains. And once it gets up to around where the coring rod is, I'll put the coring rod in. So we're going to open up this mixture. I see that there is. I'll wait to pour it. Okay, come on. Okay, I got it back. Right when I'm about to do the fun stuff, it starts. All right. Nicely even mixtured, consistent color. Put that in there. What it looks like, it looks kind of like dirt on Mars, kind of, I guess. There'll always be some clumps, so I move it like this to get some of the clumps to the top. You'll see, there's not many, but there's a few, so I'll push them out like this. And once everything's in here, I'll turn it up to medium heat. And the goal is just to mix this evenly and keep on stirring. Off the bat, I really don't need to stir too much when it's heating, but once it starts heating, I'm pretty much stirring it and pushing it against the walls of this pot to break up any large clumps that I got. This was turned out pretty nice. There's not many clumps. I just got this potassium nitrate skipped in yesterday, so it's a new batch. It's brand new, so it's working out pretty good. So we're gonna all the clumps are out. We'll give this a minute or two. Also, I'm wearing safety glasses. I have a fire extinguisher nearby, and always make sure you do this safely because I am doing this inside. It is freezing outside. This is also where my studio is. Um, okay, where are we? Yeah, so a cooking thermometer. That actually, I haven't grabbed that yet. I have a thermometer right here. This is what I will use to get the temperature. All right. So, and- right, so this will be heated to 250 degrees Fahrenheit. I'm sorry for Celsius out there, but we're gonna go to 250 Fahrenheit. Make sure everything's melted properly. It's also not a dangerous temperature. Yeah, I've looked at some of the Richard Nash. Yeah, I've seen some of his. I've read some of his documents. Also, obviously, um, this propellant, I call it NACA modified because I gotten the base for the what percentage that he uses potassium nitrate to sorbitol, but I have modified it with adding red iron oxide, and also I have two different mesh sizes of potassium nitrate in this. So I have from him, but I have modified it to my liking. I've added those things to it. I experimented with a lot during SN2's test campaign, it's 4 tests. I've tested a lot through it. Some tests were fails. Some tests went well. I experimented with adding SLS, sodium lauryl sulfate. I also experimented with more red iron oxide. I've also experimented with adding aluminum powder. Um, and then I also just experimented with the percents of how much potassium nitrate, granular and milled, to how much sorbitol. So I've done a lot of propellant tests, and I think I've landed with this one. Propellant should work great in SN4 because it looks great. This exact formula of propellant I've used in SN2 or SN3, sorry. SN2 did not use this propellant. It was very SN2 used a very similar propellant, but obviously, not this exact propellant. All right, so through the heating stages, we'll see how it starts getting clumpy. Gotta make sure, gotta make sure there's no propellant on the side of the walls. Then once it starts to become a liquid, I will turn it down to low temperature. Medium temperature just helps it initially melt down into liquid quicker. Check the temperature for you guys. We're at 188 Fahrenheit. All right. Now it's getting darker, more clumpy. I also have a spoon. It's called Mix to help me get some of this propellant off from the side so everything gets mixed in there evenly. All right, at this point, we're going to turn it down to low. Start mixing. Also, if the camera cuts out while I'm pouring, I'm sorry, I'm just going to need to leave it because once this gets to temperature, I pretty much need to pour it. I really can't mess around too much with the camera. All right, 205. We're on low heat now. Being very liquidy. Sorry, I should probably be in this mode. So let me know in the comments if I didn't switch the views and if you want it switched. All right, it's pretty liquidy. Honestly, I can see by how liquidy it is and know exactly when it's around 250 Fahrenheit just by experience, but I do still use a thermometer. It is good to be safe. Right, 240. Heat it up a little bit more. All right, we're there. So we're at 245, which doesn't need to be exactly 250, but that's where I target. We're gonna grab This is where the difficult part starts. We're gonna grab this, put this in here. Now, grab this. Pour slowly into each penicil grain. Well, not grain, but compartment, I call it. I don't know. Make sure each side the proper. I'm sorry, the views are probably very bad on this. All right. We'll put this propellant back on the heat. Now we're looking. It's around all the penicil grains. I'm gonna grab this. Sorry if my hair gets in the way. Trying to look over. All right. Make sure. Look at this. Now this will be turned off. We still have a little bit left. I'm gonna monitor that just to make sure it doesn't get at 240. Great. I'm gonna work this down. I'm sorry if this is loud. If it's too loud, I do have voice isolation on with my microphone. If you can hear all this banging, you want me to mute myself when I'm doing it? Let me know because there's a lot of that banging to go. Okay, now once that's in, I'm gonna grab the coring rod. Now, once the coring rod's in, we can do the rest of the pour. We'll try to get as much scraped down as possible. We don't waste any of this propellant. All right. Stop right there. Spin it around. All right. A little bit around the edges. We'll grab. A little left. There we go. And now, just to, all right, so obviously there's a little left in there, but also to clarify, I am not measuring how much propellant is going into this by met through this. I will, after I pour all this propellant, I will remeasure it because I know how much each tube weighs because I measured them out beforehand. And that's how I know because it's very difficult to get all the propellant out of the pan. So that just for clarification, if you guys were worried. Now, sometimes a little propellant gets up to the sides. There's a little bit up on sides of this. All right. Now please let me know if the pounding is loud because now we're going to grab the top plate. The video comes back. I'm gonna grab the top plate. I'm gonna slide that on to center this coring rod. And then I just gotta tap a lot. Yeah, please let me know if you want me to mute myself. If the tapping is loud. If you can't hear the tapping, then let me know. That'd be great. It's still very hot. If I grab temperature from the outside, it's 150 degrees from the outside. It's warm to the touch. Not. I grab this base plate, which is not warm at all, and then I hit it like this. All right, so this is off just to make sure. Yeah, everything's off. And now I got to do this. You can't hear the tapping. That is great. Oh my gosh. Okay. Guess I like to put better. I thought you were gonna be able to hear it. It's pretty loud for me. Now we'll lift up this. And I know, I'm sorry you guys can't see it, but the propellant in there is very smooth. There's no clumps. For the future, if this live stream goes well and a lot of people watch it and I get a bunch of likes and people enjoy it, I will consider getting multiple cameras to get multiple views. Because right now with the overhead camera view, you guys really can't see within the grain. I can see it, but I will get multiple cameras because I was thinking about having an overhead camera and then also a camera I can move around, a free camera that I could switch between. All right, and our next side, we got this. All right, tap that. Yeah, like I was saying, the finicil section of this propellant grain is the most difficult. I got to tap it the longest because there's all those extra surfaces that bubbles can cling to, and then also it's a pain because the finicil, I need to get into each compartment of the finicil so each side is evenly filled. Once the finicil segment is done, which it's done, I just gotta wait for it to cool and harden. I will be able to then come back and then add the second layer on top of this and pretty much just build it up like I like to say like it's kind of like a skyscraper. Start at the bottom, then I'll add the second section. So I haven't seen that anywhere before. Let me know if have any of you guys seen that technique anywhere before. Um, yeah, I could. Yeah, yeah, it would help. I was thinking about getting a vacuum chamber, but I don't think this rocket candy, it cools really quickly, and gets thick. It's already, if I go over to the pan, it's already thick. It's already all on the pan. I was thinking about getting a vacuum chamber to be able to vacuum out most of the air bubbles, but by the time I take it off the burner, put it into the vacuum chamber, pull a vacuum, take it out of the vacuum chamber, and then pour it, the the propellant's gonna be already pretty viscous. Yeah. So then you're gonna reintroduce more air bubbles that way. So I haven't used a vacuum chamber. A lot of people have recommended it to me. If I was making like HTPB, HP, whatever, I would. But Rocky Candy really doesn't help out with that. And I've done multiple segments where I've casted a grain, cut it in half, and checked all the faces around the finicil to see if there's any bubbles. There's very minor bubbles, but very small. So there's no issue with the performance. Getting the performance that I'm looking for. I'm getting the performance very close to what the performance is saying in open motor, which obviously open motor simulates with no air bubbles in the geometry of the grain. What's up, Zero G Print? How you doing? Yeah, exactly. It would be rock solid. With other propellants, sure, it's a great idea, and I think everyone should use it for other propellants. But rocket candy, I really can't see it unless I have like a heated vacuum chamber. But then that introduces so much money. I don't want to. I'd rather do it this way, which is working out fine, and invest that money into somewhere else. I could, if I really wanted, I could make this perfect, but at the end of the day, not every aspect of the motor needs to be perfect to make a great motor. UOG Prince, you missed the best part. We're almost done. I was gonna, um, but you won't miss much. I am gonna I'll let this harden for a few hours. It's currently 1:21 p.m. where I am. Count where you guys are from, like what country or state or yeah. I'm just curious. But yeah, it's around 1:21 p.m. where I am. So I will probably go live later doing the second pour. Are you no APCP? Yeah, I am going to. That's probably going to be. So I'll give you guys a little bit of a behind the scenes view into what the channel is going to become. So the videos that I'm currently working on, the big videos, I'm going to post and release some smaller videos in between each video because the big videos take a long time. I'm going to be because I want to be releasing around once every other week. I know I'm not at that point right now, but the plan, the future plan for the YouTube channel, I would love to. I'm going to finish up SN4. I'm going to post the SN4 video. That's going to be hopefully by the beginning of next month. I'll be posting the SN4 video. Right now, I'm working on the rocket. Um, that'd actually be cool. I'll actually, if you guys are interested, let me know. I'll pull up some of the CAD files for the rocket right now, and we can go over it real quick, um, or however long it takes. We can go over the rocket, but that's where I'm going. So I'm gonna have SN4 video. These are the large videos. SN4 video. And then after the SM4 video, we're gonna do the rocket video, which I'm thinking it's gonna be series, the build video, the design video, build video, and then test and launch video because I think separate videos would be better because it's gonna be a huge project. I'm yeah, like I was saying, I'm working on it now, so um I will pull some of those step files up in a second once I tamp this down. It's all ready to go. But yeah, once I do the rocket, I am planning. Then once I do the rocket, the SM4 and the rocket video are planned to me next. Then I have a little bit of options. The next video after the rocket video, I was thinking about possibly making a consumer grade rocket motor that anyone can make. It's going to be way smaller, and now everyone's like, I want this. It's going to take some time because I really want to make a motor that is very consistent. I'm going to be measuring the thrust. Obviously, you can go on YouTube and find a video about how to make a rocket motor, but they're not going to give you all the statistics on, everything. I want to tell you how much the pressure is going to be inside. I want to tell you how much the thrust is going to be and how the average thrust is going to be. So then you could build this motor and then put it right into a rocket. I'm going to test it multiple times. Obviously, I don't want it blowing up on you guys if anything were to go wrong. So I'm going to test it multiple times. It's going to be way smaller than these motors. And once I do that, I was thinking about APCP motor, small one. It's not going to be any size of the sugar motor. But the good thing with APCP, um, it's way more energy dense. So I can make a motor that is way smaller and has the same capabilities of the Rocket Candy series I'm making right now. Let me get 1222. Okay. So Rocket please. Everyone want to see design. Exit velocity. I right now I do not measure exit velocity. I'm planning on working on that. But right now, for the next test, I'm going to have a pressure sensor, which I could show that too, which that's a new piece of hardware to measure statistics in the environment inside the motor. Um, yeah, so I'm not understanding what is RCS, zero G plants. Because yeah, I would definitely RCS like reaction control system. I know it's not that, but um, yeah, I would definitely for my consumer grade a motor that anyone can make. It's going to require no machine parts. It's probably going to honestly look very similar to this that I was showing earlier. I know Zero, you weren't in it, but these old motors I'd make. with the clay cap on the one side and made out of cardboard. I wouldn't recommend, I wouldn't ever make a motor out of PVC and then recommend it to people to do because like I was saying, and like you guys know, PVC isn't the most safe way to make a rocket motor. Same thing with metal. It's not going to be made out of metal like aluminum. Obviously, SN4 and all of the other motors were made out of aluminum, but I really wouldn't say this is a consumer type of motor. It's very SN4 or SN3 last test, right? I don't think I've shared this, but right before the explosion, it got up to 100 pounds of thrust, which um, which is pretty substantial. So that, yeah, that's 45 kilograms of thrust. Um, that's why the propellant is a little less in SN4 because this is actually gonna be flying on a rocket. SN3 was really made to push the limits. I was actually pretty excited when it blew up. I knew it wasn't going to fly on a motor, fly on a rocket. So I was pretty excited when I saw it blew up. It was pretty cool. I think we're very far away in a safe area, but yeah, yeah, it does. The PVC is nasty with the fumes. All right, so let me just tap this a little bit more, and then I will open up some of the step files. Aerotech, Aerotech. I'll check that out after this stream. Yeah, let me tamp this a little bit more to get the air bubbles down, and I will pull up some of the step files for the rocket. All the step files for the rocket right now are not, don't take them with a grain of salt. They're going to change. I'll tell you that right now. They will change. They're not going to be how they look. It's going to be pretty, it's going to be pretty similar. There's going to be a lot of small changes. Comment below if you want to see the rocket parts. Well, in CAD. We don't got any yet. There's actually exciting. I don't want to hype it up that much, but there is going to be a rocket part that is tested on the stand with SN4 during its first test. It's going to have a rocket part connected to the motor. I don't want to hype it up at all because when you see it, you're going to be like, oh, okay. It's not even that crazy. But I think it's exciting that the first rocket part is going to be tested. Well, actually, second rocket part, because the first rocket part was part of the vertical test stand for SN2's um, for SN2's test with a flame trench. That part was a Pathfinder part for the rocket that will help retain the motor. Yeah, so with the convergent and divergent angles, I really played with uh, open motor. I use open motor a lot with simulating. The simulations aren't great. It's always better to test than use a simulation, but the simulation is good for the design part of the. Yeah, so I have played the convergent and divergent angle for SN3 and SN4 is exactly the same. All internal nozzle geometry is the same. You guys saw that the external nozzle geometry is a bit different between SN3 and SN4. But yeah, SN1 had a different geometry, SN2 had different geometry, and SN3 and SN4 are going to have the same geometry that is really refined, and it works great for me for this specific motor. I don't know the numbers off the top of my head. I think it's 44. The half angle is 44, convergent 15, divergent. I'm sorry, I don't know it off the top of my head, but I definitely don't know SN1 or SN2 off the top of my head. But look back in older videos. I can get back to you. All right, so let's check this out. All right, we'll give 2 more minutes, set a timer, 2 more minutes. Let me know when 2 minutes are done. And then I will, this brain will be hardened enough where I can let it sit out. Oh, the anodizing part. Yeah, so most of you guys don't know, Raphael, you're probably the only one who knows this, but uh, SN4's nozzle is going to be anodized. That's why I went back to aluminum. The anodization, I'm not 100% sure if it's going to work. I did some research. It looks like it's supposed to. I got hard coat anodized. Um, it looks promising, but obviously you got to test to see how it's going to work. So the good thing with the nozzle being aluminum and hard coat anodizing, if there's any issue where it melts out or it reacts like SM1's nozzle and melts away, that will require, well, also this is melted away between 6 tests, so it's actually not that bad. Um, there's no melting on the other face. But yeah, if there's any melting away, that's not going to jeopardize anything with the rocket. There's going to be 0 more tests. If that's the only issue, if I test SM4 and everything checks out to be great, except for the nozzle melted away, that's not going to require any more tests before the rocket. I'm just going to swap out that nozzle back to a maybe an aluminum one and test it again while we launch it, or switch back to a stainless steel. So that is good that those specifications aren't going to jeopardize the actual rocket and how long the rocket's going to take to develop. All right, let me do one more tamp and then we'll be ready to show the part. No, don't feel bad. I mean I did my own research, so if it doesn't work, it's on me. You introduced me to it, so I'll thank you because if it works, it'd be great. Yeah, you introduced me to it. I did a lot of research, um, and it looked great. So yeah, it looked great. Graphite is also a good option. Yes, graphite is a great option. It's probably the best option, honestly. But I don't have a lathe, and all these machines, I've reached out to probably 30 machine shops, and none of them do graphite. So that's why I'm doing this. Graphite's very abrasive to material to the lathe. If I had my own lathe, I could, but it's tough with cement. That is funny you said that because I have experimented with cement before. Uh, this. All right, let me just tamp this one more second. Let me check it out. Let's make sure it's good, and I will show you that cement because it's funny you bring that up. So, all right, we'll put that all out to the side. So, like you were saying, experimenting with cement because between SN1 and SN2, I probably designed in CAD. I didn't actually make any of them. Well, I made one of the design. I designed around 10 nozzles that could possibly work. And then I landed on the hybrid nozzle with the stainless steel insert and the aluminum. It worked good. It didn't work great. So, but it helped me. It was like a pathfinder for SN3's nozzle, which was then fully stainless steel, which it worked great. There's no erosion, but it's just a little heavy. It's not crazy heavy, but yeah. So let me go down here. So I've tested with multiple cements. So I had some, come on, what's going on? So I used this JB Weld. This was not on the SN series, not on SN1, 2, or 3, or 4. This is on smaller motors. But I used this to line it. It's JB Weld. I used furnace cement, which was a complete failure because it didn't harden up. And then I tried plaster of Paris, with certain amounts of sand mixed into it to help insulate it. Um, because the cement is a really good option for a cheaper. It's very cheap, easy. Well, it's actually tough because you got to cast. All right, we're all done with this. So yeah, the graph. So that's why none of these big companies will mess with graphite. Okay, I'll be back in 1 second. I'm gonna mute myself. I'm gonna go wash my hands, and I will be back to talk about the rocket. All right, I'm back. Let me know if you can hear me good. Okay, so let's see. Would you guys be interested if I come back live in around an hour and a half to 2 hours? Would you guys? I know sometime the timing doesn't work in some where some of you guys live. Um, if it does work out, then let me know because I will come back live in around hour and a half and 2 hours. Let me know if you'll be there. Okay. Oh, I'm sorry, I forgot. Someone asked what country I lived in. I totally forgot to answer that. I live in the United States. United States East Coast area. Okay. All right. Got this. All right. So, who wants to see some rocket parts? Let's get up there. That's pretty. Okay. I use Onshape. I learned SolidWorks in school, but back when I learned SolidWorks in school, you need to pay so much for it, so much to get it. But now they actually it's a membership for students. It's only like $15 a month. So I'm thinking about switching back to SolidWorks because I'm way better at it. But at the same time, I've been using Onshape for 2 years now. So I feel like now I'm better at Onshape. But yeah, I'm in the process of changing back to SolidWorks. Let's okay. Let's where's OBS? Right here. Add. Give me 1 second just to add my browser into. Oh, but no, I don't want that type of browser. I want to. Um, I'm sorry, I'm just in. That's okay. Yeah, 12:30 a.m. That's pretty late. I'll have more. I'll have more live streams in the future tomorrow and other days. So okay, I'm just sorry. I'm trying to make an element so I can share this. No, not a media source. Browser. Okay, give me 1 second. Yeah, with the anodized part, I was able to pick if I wanted multiple colors. Forgive me, but I chose no color. But I do have some other anodized parts for the test stand, which I anodized to a certain color. I should have, honest, looking back on it, I probably should have anodized it to a certain color. It looked probably pretty cool, but I changed it. I just kept it natural. Now, this is my whole screen then. Oh boy, that looks weird. All right, let me know. How does this look? Type in the comments because I do have the comments. I have the comments right next to me. How does this look? I got the comments right there just so I can still see the comments. And then I got my on shape over here. So if you guys want to let me know how this looks. Yeah, exactly. That's why it's better for evaluation. Sure, if this works in the future, and everything checks out to be great, I will probably go to colors. But for the first test, it's definitely smart just to go with color or no color. Sorry. I'm what I'm seeing through. Can you see the whole screen? My whole because I'm live right now looking through, and it doesn't look like you can see that great. You can only see like the top left of my screen. Oh, yeah, you guys could only see the top left. Not great. I'll try. It's gonna need to. Okay, it's gonna be cropped a bit, just so I can get it through the whole thing. So let me know how this looks now. And if this looks good, we can look at some parts. I got hard coat anodized. There was multiple options, so I did pick hard coat. I need to make sure they had hard coat. I actually talked to them. Uh, I do have a very I have a cool announcement in the next video regarding this company. I'm not gonna leak it yet. Okay, so this looks good. You guys can see the comments on the right are just so I can see the comments. I could grab my iPad or my phone to pull it up, but it's way easier this way. Okay. So what do you guys want to see first? You can see some of the parts. There, this right now it's very this is new stuff. This I don't have too much. It's not too complicated. All of this is gonna change. I'll start with the fin can. Fin can, the actual the fin geometry is totally arbitrary. I just drew this up. The outer diameter is 3 inches, and the actual diameters the of the outer walls of the tubing is correct, but the actual fins itself is just totally arbitrary numbers because I am running simulations uh, frequently. Okay, so this is a cut. This is where SN4 is going to slide into. Now, a lot of people so let me. A lot of people did say how the bolts protrude from my motor. How I'm going to counteract that is there's going to be two rings that are on the outside of the motor, that the rings protrude slightly further from the bolts. So the the ring's outer diameter will be very similar to the inner diameter of the rocket. So it still is very easy to slide in the motor with also having those bolts on the outside. Yeah, open rocket, yeah, that is what I'm using right now. So yeah, that's the thing can. Most of this stuff is just arbitrary numbers, just to sketch it up. The avionics bay, here's the coupler, the outer diameter is the coupler, then we got this is actually assembly. Because we got the top plates, nothing, not much in here. Um, but you can see these top plates that will be these two smaller holes on the top will have the threading for the avionics going all the way through it. And then the top one's going to have two bolts coming out of it and O hooks. That's what you want to call them to be able to hold the shock cord for the parachute. What tube am I using? Yeah, it is dual deploy. What tube am I using? I'm using fiberglass. I'm not 100% sure who I'm going with yet, where I'm getting it from, but I will definitely include that in the video. If you guys are interested in that. What electronics? I was thinking about the Easy Mega V3, I think it is. Um, I'm having an issue because I am not, this will be the first rocket that I make, and this rocket's going to be pretty powerful. So I'm not great with the rockets. I'm learning a lot right now. You guys probably know more with rockets than me. But I'm having an issue because I'm reaching out to all these companies that sell the Easy Mega 3, and I look on the sheets, the spec sheets, and they say that you can, with an extra pyro charge, be able to output a camera for a camera to start recording. But I've gotten the software, the Atlas V something software, and I'm not 100% sure how to do that. So I'm still working on that because this rocket will have I possibly possibly three cameras, 100% two cameras. There's gonna be two cameras, possibly three cameras. There's gonna be a camera faced down, faced out to the horizon, and then possibly a camera faced up just to see that separation at apogee for the drogue chute to be deployed. I really want to make sure I get enough footage. Um, Let me just get my. All right. Yeah, so that's the avionics bay, the shell of it. I haven't modeled any of the electronics or the bolts yet. And then we got the nose cone. This is just completely modeled from the nose cone that I think I'm going to go with. 5-to-1 ogive, ogive. Then we got the coupler bulkhead. Those are the motor rings. We got some SN4 stuff. Here's all the SN4 stuff. Um, so there's not much with the rocket, but I worked on I've been working on the rocket a lot like 2 weeks ago, but I've been stopping because um now I'm focused on SN4 mostly. Yeah, the carbon fiber with the yeah, that is I well I used to, I still do sometimes. I fly FPV drones and carbon fiber and electronics don't always go great together. especially I've had issues with my RF antenna and RF transmitter, also with my VTX transmitter not being able to transmit video good because it was near the carbon fiber frame of the drone. So yeah, I do know. Also with the shorting out, if it is conductive, so it will short out your electronics if they're touching. It is very that's why I went with fiberglass. Cheap fiberglass is also cheaper and um be good for my application also that I don't need to think about all those other. Yeah, I probably will. I won't drill the hole in the nose cone, but probably in the avionics bay there will be a hole. There'll also be a hole for. There's probably extra to do a hole for the pressure sensor, um, the barometer inside of the. But I'm gonna drill a hole just to make sure the ambient pressure outside is the exact same pressure inside. This my flight computer will have GPS and also barometric sensors. Kate 3. Oh, Kate 3. Yeah, the Easy Mega was Easy Mega was like 300. Yeah, definitely be out of my range. But yeah, the Easy Mega 3 said it can power on cameras. And I'm just gonna be using same cameras that are in an FPV drone that I'm gonna be using some pretty I'm not gonna be like BPS space with GoPros. I'm gonna be using some 1080p and 4K cameras, but they start recording on power up. So it'll be way easier to wire it all up because it'll just I'll need to somehow configure the two or three pyro charges that will be for the camera to power up right when the flight computer is powered up. Uh, so the cameras power up because the cameras power up automatically. You ready to go? Okay, I will remember all this. Yeah, Arduino. I was thinking about Arduino too. I got a bunch of them. But it introduces so much more work with then you're really coding everything yourself. Do I plan on releasing plans publicly? Yeah, of course. Same thing with SN3, SN2, and SN1. If you ever want the parts, please just email me and reach out. I won't really, I won't really release like SN1, SN2, or SN3 publicly because they really aren't great designs, and I wouldn't love people to build them. But if you email me and want them, I will be happy to send them to you. Maybe you can use them to learn on what not to do. But I just wouldn't want to release it publicly for people then to see it, be like, oh, let me build this rocket motor. Because honestly, SM1, SM2, SM3, I wouldn't recommend anyone to build because I don't want anyone building a rocket motor that I don't think is great. We'll see with SN4. I think SN4 is gonna be great because I don't want to be sharing stuff that could possibly explode or it's just not worth the money. Like SN1 is too expensive to be melted away, the interior to be melted away after two tests. But yeah, I think my email is in my profile, in my description, or if it's not, it's just aeropropulsions@gmail.com. You had some problems with igniters. Yeah, so what propellant are you using? I have done a lot with igniters. Yeah, zero G prints. I definitely wanted a GPS transmitter and tracker, because it'd be really cool too. So I know where the rocket lands, say if it lands very far away, and also be cool to see all that flight data after. Okay. Approximate weight of SN4. Yeah, so it's on my channel post. If you guys aren't active on my channel post, I did post it. Oh, the full mass. I think the full mass, it is on there. Pretty sure. I just posted like a quote unquote promo video for SN4. Um, and I added some of that rough. I'm not 100% sure yet. With all the CAD and estimating how much propellant's gonna be in here, I got a pretty rough number, but it'll be within, it'll be pretty close. But I will make sure to add that to the actual video. Yeah, my cameras will need their own batteries. Also, I would like to do that just in case because I don't want the camera batteries. I want to have these systems separate from each other because say there's something a problem with the camera batteries. I don't want the camera batteries affecting the flight computer because obviously the flight computer is the most important part. And other way around, I don't want the flight computer batteries messing up with the camera batteries, so they're going to be independent batteries. A matchstick with some wires. Oh, so I see what you're doing. You're heating up a wire. You have a match head to the end of it. I recommend, let me get rid of this. I would recommend uh electronic firework igniter. That's what I use right now. Let me see if I can find one. I'm not 100% sure where I have them. I have a bunch of them. Um, that's what I've been using. And all you got to do is hook it up to, even if you don't have a crazy ignition system like I have buttons that I click, you can run a wire and hook up a 9 volt. Push the 9 volt on each terminal. It'll heat up the end. I don't think I know where they are. I'm sorry. Right now I have a little bit of a mess down here. Whenever we're getting ready for a test campaign, there's always a mess because I have so much going on. But yeah, I would definitely recommend looking up um, firework igniters, using those, and putting a ball of propellant on the outside. Okay, I'm gonna have 2 minutes left before I go. I'm gonna go eat real quick, take a break, take probably honestly not too long of a break. I'm gonna take 45-minute break, and I'll be back to pour the next part of the propellant. But yeah, firework igniters. I haven't heard skips before, but yeah. Yeah, so that's what worked out with me. I made this really complicated igniter for SN2, which it worked, but my new method for ignition is using a firework igniter with a ball of propellant, and I have a black powder. I don't have too much black powder, but I have a little bit of black powder lined in the propellant to heat up it when it heats. Um, this is looking great. All right, this is still warm. Let's see how hot this is. 100 degrees. It's still 100 degrees Fahrenheit. Yeah, I hope it works out. If it doesn't work out, let me know. Join the live streams whenever. How will SN4 be lighter than SN3? So SN4 will be substantially lighter because SN3 also used a stainless steel nozzle, and the nozzle for SN2 or S sorry SN4, the nozzle for SN4 does have more volume, a little bit more volume, but it's made out of aluminum, so aluminum's way less dense than stainless steel. I'm pretty sure after the geometry change and everything, don't quote me on this, but it's almost half the weight. SN4's nozzle is almost half the weight of SN3's nozzle. Also, SN4 is going to have a slightly shorter tube because it's going to be holding slightly less propellant. And then SN4's bulkhead does weigh a little bit more. So with all those changes, it's mostly from the nozzle. The nozzle really cuts most of the weight. Nozzle cuts most of the weight, then the casing cuts a little bit of the weight, and probably the weight that the casing cuts gets counteracted by the bulkhead being a little bit more heavy. So it's pretty much just coming from the nozzle, which that's why if this anodized nozzle works, it'd be great. If it doesn't, then like I was saying, it doesn't jeopardize anything within the rocket or any problems. I'm just gonna each test of SN4, I won't be making another motor. I won't be making SN5. I'll just be swapping out the nozzle for SN4. Well, it's hard coat anodized, so it might not melt. Um, Not sure. We're not sure. That's why we're testing it. With the research I did, it looked like it could work. It could work. So that's why I'm doing it. No, speak as much as you want. It's good. I like the engagement. Um, it's better than everyone being in here not saying a word. I like communicating with all you guys. I learn from you guys. You guys learn from me. A net positive. You ignite your motors from the end. Same. I do too. My Now it looks like I ignite it from the forward, but the wire, the wire, the wire does come from the front, but the actual igniter part of the igniter, that makes sense, gets pushed all the way back to the bulkhead. I know possibly you ignite them by a hole through the bulkhead. I was thinking about that, but I think it's just easier to do it from the nozzle so I don't create another hole where something can go wrong. All right, I got 2 more minutes, so you guys want to ask any last questions? I'll be back in like little less than an hour for the people who will still be awake. I know some people it's late. If you haven't liked the stream, please like it um, before we leave. And then I will be going live again. I think I'll say part two or something, just so you guys know. Make sure you guys have post notifications on because you will get a notification when I go live. But I will right after I'm done with this, I will go into YouTube Studio and add the live in, so you'll know when it's going to go live. There will be a countdown timer there. But if that wraps it up, I appreciate you guys all for watching. The first pour is looking great. I'll be back in a little less than an hour to do the second pour. And yeah, everything's looking great. Thank you for watching, and I will see you guys in the next live stream. Stay updated.